All right, well, let's go ahead and welcome everybody back. We are excited to give you our next talk, and I've got a sneak peek of this one, and I'm very excited for it. Brian Moran from his own Brian Moran Labs is going to be presenting along with Kevin, who is with KPMG, and they're going to be talking about an artifact that's been hiding in plain sight for quite some time. And I'm not going to steal too much of the thunder because I know you all have a whole bunch of good stuff ready for us, but I love your talk title. You guys, you're always creative with the talks. Where have you all been? We were talking about the origins and uses of YAL earlier, but this is a different one. This is the user access logs. So we are going to shift to the individual channel. So in your hallway channel, we'll have the conversation. We'll direct you over there. And thank you very much for sharing your time and sharing your findings with us, guys.
Thanks, Phil, for the introduction. Hi, everyone, and welcome. Thank you for joining this session with Brian Moran and myself today. For this session, we'll be discussing what we are calling the Where's Waldo of forensic artifacts that's been hiding in plain sight for quite a while until this year. Moving on, hi, I am Kevin Stokes. I've been doing digital forensics work for over 8 years now. I started working with KPMG in the Cyber Response Services group a couple of years ago. I want to take this moment to thank Brian Moran and other friends and coworkers who encouraged me to take part in this presentation. Just a random fact about me, back in the day, I used to have a fun time playing trombone in a community band. Here's Brian Moran.
Well, hello, all you cool cats and kittens. My name obviously is Brian Moran. I spent 13 years in the Air Force. After that, transitioned to the civilian sector, have been doing that since. Have about 20-ish, almost 20 years in the mobile exploitation, as well as a kind of DFIR primary focus. And random fact about me, because I love doing this in any presentation, is for those of you who don't know, I actually own an Atari 2600 ET cartridge to remind me every single day, like no matter what I do, like never ever mess up so badly that I actually make an ET.
We want to take a look back for a moment to 2012 and consider some great things that happened almost a decade ago. Of course, we have Marvel's release of the Avengers movie.
Felix Baumgartner, sponsored by Red Bull, jumped out from just over 128,000 feet and actually broke the sound barrier without any machine assistance, which is an amazing feat all by itself.
We have David Nides at KPMG, wins the Forensic Forecast Award for Digital Forensics Article of the Year for cheating timelines with Log to Timeline.
Microsoft, back in 2012, obviously released a new server OS and cleverly called it Windows Server 2012.
We also found a 2012 article from Brent Foreman, who provided us an early write-up on the new, at the time, user access logging feature we are discussing today. Here, Brent goes over the UAL architecture and PowerShell commandlets, along with examples and output. So let's see what this is about.
And of course, no retrospective look would ever be complete without share. And of course, if I could turn back time, I'll save you all from the horrible singing attempt, of course. But you know, I'm sure you can picture it if you know me. So the quote of the day from Brent Foreman, who made this blog post now almost a decade ago, is he's very, very succinctly stated that this service is intended for administrators only. And obviously, as we go through this talk, like you're going to realize that it isn't really for administrators only.
So in this presentation, we intend to provide a mostly high-level view of our own research and information about user access logging. The reason why we are just providing a high-level view is we want to include Brian's work on accessing and parsing the log data for review when needed in your own investigations. We also want to recognize additional information shared by others in our community, along with noting Microsoft documentation, so that you have a good amount of resources available to you. And moving on. So user access logging, also referred to as the other UAL logs. The original purpose of these logs was to allow administrators additional visibility into usage of server resources, at least in part for licensing management. These logs exist by default on Windows servers going back to 2012 and look to be in our future for Windows Server 2022. Continuing on. Why do we care about these logs? Well, these logs can be pretty useful in certain situations, allowing an additional resource if you need to go back further in time during your investigation. You can get a historical perspective of the network environment. For example, allowing you to potentially get the IP address assignment of a system from over a year ago. By default, user access logging maintains 2 years of archives from previous years, plus the data for the current year, allowing 2 to 3 years potentially worth of this data about the network. So about the files themselves, as we mentioned, these are only available on Windows Servers 2012 and up. The logs can be found in the Windows System 32 log files SUM folder. And by the way, we understand the SUM to be an acronym for software usage metrics. Here in this folder, you'll find several files, including the current database, the system identity database, and other files with a GUID in the name. And for clarity, as we move on, when we discuss the GUID archive database, we are discussing the third file here in the screenshot, which is simply just another database with a GUID string as a file name. And despite the file extension of MDB, these are not Microsoft Access database files. They are indeed extensible storage engine databases. And you'll find some other ESC related files here as well related to general functionality of this database system, which we'll discuss more about. And moving on to the overview of these files. The current and GUID MDB files are actually similar files, and they actually maintain similar types of data. The main difference in the GUID files the GUID files are backups of the current database. The current database, along with 2 years of these GUID backups, can lead to upwards of 3 years worth of data. If by chance the server had volume shadows, so be sure to check those as well for more logs if needed. Continuing, as for the other files in the SUM folder, the system identity database has a few functions. It will maintain a list of the GUID archive files the system is tracking. This table is called change databases. The system identity database will also maintain a list of roles being tracked from the server. That table is called role IDs. Another table here keeps track of information about the system itself and is simply called system identity. Other files here, such as the ESC transaction logs, temp files, checkpoint files. These are all utilized by the ESC database engine, and we have a Microsoft link here if you have an interest to learn more about ESC databases. As for the tables, the next few slides are mostly here for reference. We have information here in the slide about important tables within the UAL databases. Per descriptions here, you can see the clients table will show you the day of access for a user and IP address. The DNS table, if available, is also a great historical list of IP and hostname mappings over time. Using both the clients and DNS tables together, an investigator can get the IP, domain, and username for a particular hostname around a certain period of time. Again, potentially going back 3 years, depending on your server. We've got another reference here we included to list important columns and names along with descriptions. Some of this will be looked at later while going over the parsing information, but just to point a few out, the hostname column maintains the list of the name of assigned to the host. We have the address column that records an IP address. The user authenticated username column maintains the domain and username of an access. And we'll discuss more about the tenant ID later. As for this slide, I'm not sure if it's actually showing up right there.
It looks blank.
Yeah. Okay, well, we'll definitely fix that on the uploaded slides. But this was supposed to be a list of for the PowerShell commands available for user access logging, which these could certainly be handy for internal teams for hopefully a quick look at IP and hostname mappings. Also, an additional tool for hunting when reviewing for access related to suspected accounts.
And we promise there are commands there. We have no idea why, but there are actually commands there, and they will be in the version that we actually upload.
Right. Yeah. If you wanted to do some research of your own, there is a handy registry key referenced in the Microsoft documentation to adjust the polling interval for the UAL ESC database. This would allow for faster updating of information into the database. Aside from that, we're making no recommendation here for modifying this for general business use, just simply a research consideration. And moving on, some information we stumbled upon related to the tenant ID. For the Active Directory Domain Services role, this appears to display the invocation attribute GUID for the Active Directory instance. I personally don't know all the situations in which this attribute might change, though it will change when Active Directory is forced to perform a restoration. In that instance, the invocation ID attribute will change for that Active Directory instance on the respective domain controller. The Windows event log entry showing this change can be found on a particular domain controller through the domain service log event ID 1109. This particular occurrence from the slide was observed via a snapshot restore of the domain controller, which forced an Active Directory restore. Moving to the next slide. Here is a list of additional resources. As mentioned, Brent Forman's write-up on the Microsoft Dev blog. I've got my KPMG blog myself on this topic. Thanks also to Zach Stanford for his write-up. We found a Microsoft Japan post from last year from Kenichi Maruyama with a brief discussion of some additional ESC files seen in the SVM folder, which we're not going to discuss here, but wanted to bring this up in case you found them yourselves. Also, a big thanks to Patrick Bennett for his blog and talk at the Magnet Virtual Summit. These are all great resources here to help you get involved with understanding how the user access logging feature can assist you in your investigation. And now on to Brian Moran to discuss parsing.
So one of the things that we found, obviously, is going through this data is like, okay, they're ESC databases, cool, they have an amazing amount of information in them, but like, it was really hard to figure out exactly how everything is being stored, how we need to actually process it to actually get usable results out of it, because we found keyword hits within the files of the usernames of particular interest, host names of interest, stuff like that. But like at the end of the day, like we knew they were ESC databases, but the information out of them just was not usable at all. So initially we tried to open it up in NERSoft ESC database view. Unfortunately, when we opened it up, we realized that the timestamp, among other things, obviously, were just not correct. And let's see, there we go, just a little bit of a delay there. So obviously, we know that our incident did not happen back in 1899, which is actually before, as far as I know, computers were invented, especially Server 2012 from Microsoft. So obviously, there were definitely issues with regards to the timestamp not being parsed properly. So we knew that we had the information and then we knew we had to get it out. So we had to work on creating some sort of tool to get out the information quickly and reliably and make sure that all the data was actually formatted correctly and properly. So after stumbling across it back in January, we spent about 2 weeks trying to understand like every aspect of all of these databases that we possibly could, of all the files of the GUIDs, the MACs, how they're being stored, how they're being parsed out, everything like that. Fortunately, Microsoft has fantastic documentation with regards to how GUIDs are actually stored even within ESC databases, because sometimes there's a bit of sort of, I guess you could say, entropy with regards to the way the actual GUID is. So when you pull out the GUID, like you have to do a little bit of I guess magic, if you will, to actually get a proper usable way out of it. And then once we got that all out, and then it was just a way to try to get the data output, so that way it could actually be human consumable and actually usable through an examiner through the course of the investigation. So we created the tool called KStrike. There is the link to it. It's pretty straightforward. Nothing abnormal there. We started the kind of true development after we gained a little bit of understanding it back in January 30th of this year. Subsequent updates, we added the host names to the IP address correlation from the DNS table, if that's available. As Kevin stated, it's not always available. There are sometimes entries with regards to multi-year entries, like usually it always starts on January 1st of whatever the year currently is, or in the case of the older historical tables, the previous year or year before. However, there are sometimes multi-year entries, and we're not quite sure exactly why that is yet. We're still researching on that. But if there was, for example, only 2 entries, I can definitely say which is the first and which was the last year, and then we can do the guessing from that. We also added the GUID correlation. But again, those are pretty much like as we come across them, as people contribute them. So that way we can actually match the GUID back to a particular source name. And most recently, which is already pushed and updated, it actually has, initially it was just Python 2, has Python 3 support. And one of the reasons that we pushed for Python 3 support is because the new version of the SIF workstation has the libESC DB already installed on it, which if you've never installed libESC DB, it can be a very, very large pain and a hassle. And you're honestly probably better off downloading SIFT and just waiting, however long it takes to download 3 gigs and then run it in that VM, because it's a much faster and much smoother process. This is just an example of the KStrike screen. Once you run it, pretty much straightforward, kind of tells you the path of where the files can be found. It also stores the data in double pipe delimited, so that way it's a little bit easier for tools like Microsoft or Microsoft Excel or OpenOffice Calc, I believe it's called, if I remember that correctly, to actually install and parse properly. So KStrike does print information to standard errors just to show you that it's working, because it can take time to process. This one was fairly quick. It was only 3,300 records, so processed in just about 2.5 minutes. I think the largest that we've come across is like 24,000 records, which can take about 25 to 30 minutes to process. And obviously, just sitting in a blank screen wondering if it's actually working or not, it's not going to be terribly helpful. So we put a little bit of information in there, so that way you can actually fully realize the script, even though it looks like it's doing nothing, like it's actually running and parsing through all the data. This is just an example of the output as the raw text. Again, it's UTF-8 encoded, so that way it will actually be able to handle foreign characters. And of course, the double pipe delimited is super easy for the Excel import. So all you have to do is take the text file, that output, import it into Excel, and you are good to go. And you will have actual usable data from these database files. So one of the things that we initially got questions on when we first released this back in the beginning of the year is that, oh, well, it doesn't actually support UTF-8, or it doesn't support foreign characters, especially like the Western European characters. And it does. However, there's a limitation within Excel, and we'll want to go over that, because honestly, if you're not doing this like kind of import of data when you're using Excel, you could potentially be missing, obviously foreign characters, but host names, anything like that of the characters. So rather than get like I think they're like sort of like diamonds with question marks, and then when it doesn't quite understand what it is, like this will actually help you do that. So the first part is to open the text file with the KStrike output, or text file of whatever your choice is. Make sure that you select all files, because it doesn't automatically import text files. Turn on the text import wizard will open. And again, this is pretty much straightforward for anybody who's actually done data importing into Excel. We want to choose delimited, and then we want to pull from the file origin. We want to select that as UTF-8. And that's, again, important to make sure that you actually get the proper UTF-8 encoding, so that way it actually translates the data properly. Then we deselect tab, which is automatically selected when we do our import, and then we fill in the pipe. We choose other, and then we choose the treat consecutive delimiters as one, so that way it will recognize the double pipe as the delimiter. Then highlight all of the columns, select them as text, and then click finish, and then you have actual usable output. On a Mac, it's a little bit different. The process is similar, but of course, because it's Mac, like it's never going to be 100% the same because that's just how Macs are. So again, with the Mac, you choose open, choose your file of particular interest that you want, select the limited, and select the, again, UTF-8 as the file origin. We do deselect tabs, select the pipe again, treat consecutive delimiters as one. In this case, we again select all the columns, choose text. And then we have our output. And then, as you can see, it's very actually easy to digest. It's usable output. We purposely tried to conceal some of the information just so that way people who shared information and share data with us, as well as our own data, like doesn't actually, be consumed in any of these presentations or anything like that. But you can see that it clearly maps the GUID to whatever role name it was, tenant ID or access number, the date of insert, last access, all that stuff is all actually in there and just ready to go and ready to actually go through and progress. So now, you run KStrike, you get the output, you import it into Excel, be it on a Windows machine or a Mac, and then you have an actual easy to digest consumable output from the ESC database. And because this is a presentation, of course, that I am giving, like every one of my presentations, and Celebrate put this little gif of Heather up maybe 4 years ago, I guess, at some point. She's shaking her head no, but she's actually giving thumbs up, so it's all good. But yeah, so every presentation always has the Heather thumbs up gif in it. So there are a couple of other UAL parsing options out there. Eric has the some Ecmd, which is part of the easy tool stuff, which has been talked about at length throughout the course of this summit. The one thing to note about that is it requires the databases to be in a clean format. If you're actually getting these files from a live system, it's not always going to be clean. More than likely, it's actually considered a quote dirty database, and you may have to clean it. And Mark McKinnon actually has released his autopsy plugin, and that was actually released, I believe, at the beginning of this week, if I remember correctly. And of course, that'll probably be one of the plugins with the upcoming OSDFCon autopsy stuff, because Mark just churns out autopsy plugins because that's what Mark likes to do. So this is just an example of, again, another tool parsing it. This is the Ecmd output, pretty straightforward. It processes it. It shows you some information, says the year, parses the information out. Everything goes from there. Exports the information, kind of lays it down piece by piece by piece, and just shows you again some information. Processes it again fairly quickly. But this is just an example of, again, making sure that the tool is actually running and providing output. Now, one of the things, I'm sorry, this is Kevin, my bad.
Oh, no worries. So yeah, as Brian mentioned, it is possible these databases can be in a dirty state. When this occurs, there is a Microsoft Windows command line tool called ESCutil that can be used to remedy this. The tool has a lot of features, but for recovery, it's pretty simple. Of course, you want to export all files from the SUM folder first. We recommend using admin mode for your command line. Have ESCutil check the dirty or clean state of the database first. If dirty, you can use the /r option. R is for recovery here, along with the base file name SVC. Here, the SVC file is the checkpoint file for these databases. And finally, run ESCutil with the /p option to repair each of the databases you have. And to note, KStrike will parse the dirty or clean databases, and it's good practice to clean them up for parsing. And let's see this next slide. This is just to view a view from ESCutil showing the dirty state for a particular database. On the next slide, is it going? This slide, it just shows that ESCutil will prompt you at certain stages. So I have to click through that. And on the next one, ESCutil has this a nice status view. It usually doesn't take too long for this restoration process. And moving on, this slide shows checking that status again, and now it shows it's clean and ready for parsing. Also, your favorite forensics tools may even help you with the status check step. Just be sure to take a quick look at the file details within that software. And here you can see this tool showing either a dirty or a clean state exists.
Yep. So obviously, one of the main things that always comes up is like, so why do I care? Why do I care about this other UAL? Why is this important to me? So obviously, going back multiple years with actually being able to show like account access, host name access, stuff like that, it's hugely helpful to be able to get that kind of historical information. And of course, we do have real world examples of it. And everybody's topic, which was just discussed over lunch, ransomware, which we all know it. Unfortunately, we know it too well. I don't think any of us actually truly enjoy a ransomware case, but it does happen. It's prevalent. So one of the cases that, of course, always comes up, I guess, questions that always comes up in any ransomware case is you're always tasked with like who, what, when, where, why, how, was their data exfil, how long do they have access, all of those typical questions. So Shanna, based out of Australia, went through one of the cases that she actually worked and ran KStrike on it, and was actually able to follow the timeline back to where they actually were able to demonstrate the external IP connecting into the internal environment. And then we're able to say with definitively, like, this was actually patient zero, like this is the system where the ransomware actually originated from. So, again, this doesn't have to be just applied to ransomware. It can literally be applied to anything and pretty much any case that's being currently worked. Like, it's hugely relevant to that, especially with cases, where you have dwell time of a threat actor that's been weeks, months, even years. Like, of course, we all know system event logs, security event logs, stuff like that. They all tend to roll fairly quickly, in some cases, much more quickly than any of us would like. So this is a perfect example of data that is remnant for up to, potentially 3 years, where you can historically look back and say, oh, well, on this particular date, like, we saw that this account accessed this system from this other IP address, and there you actually can start to kind of go back through and rebuild the pieces. You can also use it to say, oh, well, back 2 years ago, like what host name had this IP address? If the DNS entries are populated in there, you can go back and you can rebuild that historical network map and say, okay, well, we know for sure that this host name had this IP address at this point in time. So there we go. Like, we can say that, okay, in an environment where not every system has static IP addresses, that is hugely helpful, where we can go back and equate an actual host name, so that, again, as we kind of use it to piece back the pieces and work through the exam, we can actually figure out kind of what was going on. And it's fairly difficult to clear. Like, it isn't impossible to clear, but it's fairly difficult to clear. So if you have a threat actor who did the typical like anti-forensic stuff and cleared logs and cleared stuff from user folders and everything like that, more than likely the UAL stuff is still going to be there. And it is possibly the only evidence that you will have of any kind of account access, IP addresses, anything like that, that is going to be hugely be helpful for your investigation.
As for future research, testing in cloud and hybrid environments, perhaps there are more role IDs to find there. It could be interesting to see about adding this data to Sentinel logs in Azure, if that's possible, for example. Of course, keeping an eye out for changes to general logging and features of UAL. Obviously, feedback on KStrike is much appreciated. Any other tenant ID information or findings about other table data that appears to be unused, like the virtual machine table or the client name field, which currently we have not seen data for. How are the logs affected by server role changes? Also, review of any anonymous logon entries. So far, we've seen these related to non-domain systems, though further review would be good for that. And then moving on, special thanks to everybody here, KPMG Cyber Response Services, Patrick Bennett, Microsoft, Mark McKinnon, and Mark Badgett.
Yeah, and ironically, like, we probably wouldn't have found the usefulness of this the entirety of UAL and everything like that without our I guess comrades, we'll call them, over at the SVR. So, like, I know it kind of sounds kind of weird, but like, tip of the cap, like, thank you very much. We do appreciate your work.
And of course, one more thing.
So obviously there was the Waldo, who is wearing a Microsoft sweater, which is actually very similar to my Microsoft XP sweater, which I've also decided that I shall wear on every presentation this year. And of course, no presentation would be properly done without two Clippies. Well, without one Clippy, but we decided to put one water Clippy and one beach Clippy. So again, Lee Whitfield, like those are both for you.
Yeah, thank you so much. Yeah, feel free to ask us questions in the hallway, and appreciate your time.
Yes, thank you so much.